Okay, we're going to walk through our participation activity that'll lead into the assignment for this unit. Hopefully you've already watched the video that should be linked up here that introduces you to the Java implementation of A star, because we'll be using that code. You can grab the instructions here. Okay, so you want to grab this code. You can either, if you haven't already, you can download the zip file or grab it from our Unit 2 assignment on GitHub. Either one will work, and bring it into NetBeans or Eclipse, whatever you're using. I'm going to be using NetBeans in this example. And again, we'll be looking at this map of Duluth with certain intersections marked as nodes for finding paths around the town. Okay. So right now the algorithm doesn't work quite like it should. There's a number of problems with it. It does what's often called a breadth first search from any point. Like if we start from 1, it'll just go explore 2 and then 3, 4, and 6, all the neighbors, and then all the neighbors of those neighbors. So it'll explore 8, 22, 7, and so on. Even though some of these might be long distances, like we'll quickly explore way up to 22, and that's a very long way rather than finding some of the shorter paths. So the first thing we're going to do is work with the frontier, and we have this list of frontier items. We're going to sort them by distance, so that we always are looking for the shortest path, not just the next path on the list. So the first thing we're going to do is we're going to run our A star as is and go from node 20 to 22. So that's going to go from here 20 to 22, and we're going to find the path that it finds from 20 to 22. So here's our algorithm. We're just going to run it as is. We're going to go from path, click down there and go from 20 to 22. And it's going to go from 20 to 18 to 19 to 22. So that's our path that it's finding. Okay, so I'm just going to keep track of that path, and now we're going to go in. Let's go back to our instructions here. And it says uncomment line 84 in the A star, which sorts the frontier list. So we're going to go back in our thing. We should see these line numbers here, go down the line 84, and then we do this collections.sort of the frontier list. We're using a built-in sort function for array lists here, and so we're going to sort the frontier list, and it'll sort the shortest ones first. So we're going to do that. Now we're going to run this algorithm again, and we're going to go again from 20 to 22. And it looks at a slightly different path here. So it goes from the path 20, 21, 19, and 22. So this is the path it finds when it's going. So again, if we look at our map again, and scroll. So originally it found the path, it just kind of does it in numeric order that's at, so it found 20, 18, 19, 22. So that's a pretty long path over to 22 that it found. Now finding shortest path first, it goes 20, 21, 19, 22. So at each point it's exploring. So from 20 it's going to explore the shortest path. So it's not going to go down to 18 because that's pretty far. It's going to go to 21 first and explore that path. And then so we can actually look and see what it does here. So from 20 it explores 21 and then 18 and then 19. So from 21 it explores 19. And then it'll explore 23. So far it's done this. So it's just expanding kind of in a circle from 20 out. And then it does 17. Again, it's expanding from circle to distance wise. And then finally 22. And then so the path it finds is over to 22 here. So that's good. It's getting improved. But again, unfortunately, 20 21, 19, 22 is not the shortest path yet. So let's do some more changes. So the next algorithm I want you to change is run this algorithm, and we're going to want you to comment out lines 22. Get rid of line 22, put a comment there, and uncomment, free up lines 80 and 81. 82 is, so let's go here and see. So in A star again. So 82 here, we're going to want to get put into comments, and the two above it, 81 and 80, we're going to uncomment. What we were doing was calculating the total length, the line we'd calculate, put in here, the total distance to our node was just the distance from the start. And this is what's called Dirkstra's algorithm. But A star wants to do two things. It wants to, when we have this map, it's going to, and we're looking at node 19, it's going to calculate the distance from the start. So 0.6 plus 0.8 is the distance so far, and we can calculate that directly. But then we're also going to estimate the distance to the goal. And we're just going to use some heuristic estimate. In this case, we're just going to do a Euclidean crow's fly distance. What's the shortest distance as the crow flies from here to here? Because that's easy to calculate if we know these two coordinates. So we do that. And so now in our code, let's get back here. We're calculating this heuristic distance, where we're just estimating the distance to the goal, and then our total distance is now the distance from the start plus this estimated distance to the goal, and we're using that as our calculation. So this will go a long way to finding a better distance. So now if we go from, run this and go from 20, click in here, 20 to 22, it'll find this goal. I'm going to accidentally typed in a 20 up here. Okay, so this finds this new path here. So our new path here, which is almost a complete A star algorithm. Again, we go from 20 to 21 to 23 to 22. And again, we can kind of look at how we expand nodes, and it's much more direct now because we're doing heuristic distance. So we start at 20, we expand 21, we expand 23, and then we expand 22. It actually finds the shortest path without exploring any extra nodes. Now, usually it does have to find some extra nodes, but in this case it doesn't. But it finds a much more direct path and searches much fewer nodes this way than in any of the previous nodes. And that's one of the benefits of A stars. It's a very fast algorithm to work with. Okay. So that's the main idea of this, but there's still an issue with this algorithm, and let's look at going from St. Scholastica to the mall. So let's scroll down a little bit. We're going to go from node 1 to node 11, and there's lots of different paths you can take from node 1 to 11. So even with our best algorithm here, going from node 1, let's click down here, to node 11, it finds this path 1, 2, 3, 8, 9, 10, 11. So it's finding this path as the best path. But that is not the shortest path. This is the shortest path here. Okay? And we'll look at some problems here, but one of the problems revolves around this 8. It first finds this path to, this node 5. It finds this path to node 5 through node 8. That's a long path here. It then finds a shorter path, but 5 is already on the frontier list, so it doesn't check this new shorter path to 5. And that's something you're going to have to change with the assignment. Okay, so we're going to have you work a little bit on the assignment. Now, this is a challenging assignment. It's probably one of the hardest algorithms and programming problems in the whole class. So I want you to work a little bit together with this as far as the assignment goes. So for your discussion, I don't need you to post anything of these paths. I want you to try out the assignment and either ask us question on the assignment, try to figure out how you might change it. If you have some code, try to post part of that code, a line or two that you think you're having problems with. And if you do find a solution, suggest, give some hints to other students how to solve it. If you don't want to do either of these, you can just search. There's lots of different, we're just looking for A-star use for pathfinding. There's other ways of using A-star, so you can look at some other those examples. And then as your response, try to answer a student's questions. We don't want to post full solutions to assignments here, but if students ask specific questions about code segments, you can provide specific answers on how to fix their code, things like that. Similar to how websites like Stack Overflow answers problems with programming. And again, if you have a suggestion, you could help clarify that or respond to someone else's description here. So those are your discussion challenges for this week, for this unit. So continue on to the assignment and use these discussions to help each other out this week.